All right, guys. So here's the last section of 9.3. All right. What we're going to be doing here is we're going to be using this formula. All right. We're going to be using this formula to calculate the horizontal distance. All right. So think about this is like, let's say, oops, sorry. All right. Let's say you're throwing something. This is the x coordinate. So this is going to be the direction. All right. This is the direction. It's going to be in feet. All right. And with this formula, we're going to be trying to figure out is if you were to throw something, how far does it go? Till it hits the ground. All right. So let's go through each one of these variables. All right. So d, that's the distance in the x direction. So that's how far something's going to go. And then v, all right. V, that's velocity. That's going to be how fast is something going. So anytime you see speed, that's velocity. So the initial velocity, all that means is just when you first throw something, or somebody shoots a rocket, or they love to do cannonball problems like this, all right? Or I'm using sports type problems here, all right? It's just how fast is something going in the very beginning, okay? And you're gonna square that one. Then the next thing, so this 32, all right, that 32 is gravity pulling the object down, all right. So just think about it in here is in our little cheesy graph here. All right, gravity's pulling this thing back down. Yeah, it's stuff that's not going to keep going forever and ever. And then um, sine of 2 theta. Well, in this case, 2 theta, whatever theta is, whatever angle they give us, you're going to multiply that by 2. All right. So if they give us 20 degrees, you're going to multiply that by 2, so you're going to end up using theta is equal to 40 degrees. Okay. So let's get started with this problem here. All right. So let's get started with example 1. And it really, guys, all it is we're just going to keep using this equation over and over. All right, calculate the horizontal distance traveled by a track and field long jumper who jumps at an angle of 20 degrees with an initial speed of 27 feet per second. So right here, here's speed, right? There's speed, so there's my velocity. Right here, there's my angle, so there's theta, all right? So let's plug in. D is equal to, what was my speed? 27 squared over 32 times the sine of 2 times 20 degrees. All right. Now, you can just plug this whole thing in on your calculator. When you plug it in on the calculator, all right, like the calculators I let you guys use in class, what you're going to have is you're going to open a parenthesis. You're going to do 27, all right, and you guys know how to do 27 squared, divided by 32. Close the parentheses, and then times. You hit sine, right? Hit the sine button, and it's going to be the same thing every single time. Open up a parenthesis for you. You're going to type in 2 times whatever angle they give us. All right. And it's going to be the same exact setup every single time for these beginning problems. So the distance is approximately equal to, once you plug all that mess into your calculator, 14.64 feet. All right. So this long jumper who's running at 27 feet per second jumps at 20 degrees. This long jumper will jump from one spot to another of about 14.64 feet. All right. So it'll be about 64 feet. I mean, excuse me, 14.64 feet from where he or she takes off to where he or she lands. Okay. That's all you're doing for these problems. All right. For part for part B. Calculate the horizontal distance traveled by a golf ball that is hit at an angle of 40 degrees with an initial speed of 90 feet per second. All right, so I'm going to stop right there for a second. Let's just do that problem. So D is equal to, well, what was my velocity? This person's hitting a golf ball at 90 feet per second. I don't play golf, so I have no idea if that's fast or not. Divided by 32 times the sine of 2 times 40 degrees. And again, I just showed you how to type that into your calculator. So D is approximately equal to, all right, so at 40 degrees, when you plug this in, this golf ball is going to go approximately 249.28 feet. All right. And that's not saying that it's going to go further, because it'll probably bounce and go further. But where you hit this golf ball to where it lands initially, where it first hits the ground, would be 249.28 feet. All right. So that was with 40 degrees. There's answering the first part. Now, what would happen to the distance as we change the angle? All right. So now I'm asking you, what if you tried those different angles? Right? What if you tried those different angles? Now, on your calculator, all you're going to do is you're just going to go and just change that number every single time. Right? I'm going to let you guys do that. What conclusions do you come up with? All right? And when I say what conclusions do you discover, what are you coming up with? Look at the distance that the ball's traveling. What patterns do you notice? All right? I don't want to give it away. It's kind of obvious. All right? It's kind of obvious, but you try it. Okay. Example 2, part A. Now I'm going to change it up a little bit on you. At what speed? So now I'm asking you to calculate speed. All right. Now I'm asking you to figure out the speed. So you're going to be solving for V this time. At what speed must a stunt driver be going to make a 100-foot jump across a river if the ramp is set to 27 degrees? All right. Oops, sorry. What happened there? All right. So we know the distance this time. We know the distance. The distance is 100 feet. So this stunt car driver, all right, car, motorcycle, whatever, I don't care what it is, has to jump 100 feet. We have to figure out how fast he or she must be going. All right. So we're going to be figuring that out. And then they told us that, all right, they told us that the ramp was 27 degrees. All right. So I'm going to do a little bit of stuff. I'm going to wait till the very end to do any calculations on the calculator. All right. Because I'll get more an accurate answer. So I end up with v squared is equal, it's v squared over 32 times the sine of 2 times 27 gives me 54. So I'm going to use 54 degrees here. All right. Now, how do I get rid of a fraction in an equation? I'm always going to multiply by the denominator. You've heard me say this a million times. All right. So I'm going to multiply by the denominator to get rid of it. So 32 times 100, 3200 is equal to v squared times the sine of 54 degrees. All right. Now divide both sides by sine of 54 degrees, because do you agree 54 sine of 54 degrees is just a number? All right. So we end up with, let me rewrite it over here. 3200 over sine of 54 degrees is equal to v squared. Now, how do I get v by itself? I take the square root of both sides. All right. I need to get rid of that squared. So I have v is equal to the square root of 3200 over the sine of 54 degrees. Sorry, that didn't come out good. All right. Now is when I'm going to grab my calculator, and I'm just plugging that whole mess in. All right. So calculator work. All right. For you guys that are still struggling, hit the square root key. Parenthesis opens. 3,200 divided by sine. Parenthesis will open. 54. Close it. Close the other parenthesis. All right. Yeah. Let me see if this will help. Let me if I. Oops. Sorry, guys. All right. Let me color coordinate those parentheses. Maybe that might help you guys out a little bit. All right. So we end up with the velocity is approximately equal to 62 point, oops, 62.89. Oh, geez. Sorry, guys. Here. Still trying to get used to this. Feet per second. All right. So about 63 feet per second. Well, what this ends up equaling, this is about 43 miles per hour. So if this stunt car driver wanted to make a 100-foot jump on a 27-degree ramp, this driver would have to be going about 43 miles an hour to get to the other side, right? Or 62.89 feet per second. This is the answer that we'll be looking for, right? But I figured let me at least make it miles per hour so we can have a little understanding of the speed. Last one. Quarterback throws a football to his receiver who is 20 yards away. All right, 20 yards or 60 feet. Because remember, all our answers, our answers are going to be in feet. All right, and seconds. All right, so the quarterback releases the football at 65 degrees. All right, so oh, I forgot to put in here. I apologize. I forgot to type in. I was wondering where the velocity is. All right, I forgot to type in the velocity. The quarterback releases the football at 65 degrees, but also throws the ball at 45 feet per second. Right? I was wondering why the problem looked wrong. Right? I forgot to put the velocity in. Okay, so now that I fixed that screw up, the distance that um, the football player, I mean the receiver, is 60 feet. All right, is 60 feet. But I don't want to put 60 in yet. I don't want to put it in because I want to know if this quarterback throws it at 45 feet per second at 65 degrees. Does the football even make it to the receiver? Does it fall short or does it get overthrown? All right. I want to know if this quarterback is a quarterback from the Bears that we've had. So I'm going to put distance is equal to 45 squared over 32 times the sine of 2 times 65 degrees. All right. So I type all that stuff in. I already showed you how to type that in. So the distance is 48.47 feet. All right. So that's how far this ball goes. If this quarterback throws the ball at 45 feet per second at 65 degrees, the ball goes 48.47 feet. Well, what ends up happening? Right, we know. All right, so here's the quarterback. All right, there's the quarterback. The receiver, the receiver is 60 feet away. All right, so if this is 60 feet from there to there, if that's 60 feet, this ball only goes. The ball only goes 48.47 feet. So what ends up happening? The football falls short. All right, we have a really, really, really weak quarterback here. The football falls short. It doesn't even make it to the receiver. So the receiver doesn't even have a chance. All right. So hopefully these problems aren't too difficult. You notice all we're doing is just plugging stuff in. All right.